All right. Today, me and Myles are going to do a presentation on continuing the SE department throughout the pandemic, which was a lot more difficult of a task than it might seem at first. But first, just a little bit about us. It's a photo of us at the interest meeting. I'm Sam. I'm the president of software engineering. I was the vice president last year, and I co-led with Myles the Infinite Recharge at Home group.
Mm-hmm. And I'm Myles, and I'm the vice president this year. The only cool thing I did last year was co-lead the IRH group, right, which we'll talk about.
Yeah. This is yours.
All right. So throughout last year, we realized there are a few principles we want to hit to have a successful year in SE. That starts with building an engaging newbie ed program. So newbie ed is just a way we teach new members, right? Because we assume members have no knowledge. We teach them all the skills we think would be necessary to participate throughout the year. All the previous years were not on Zoom, and Zoom, newbie ed becomes a challenge when everyone has their camera off, nobody wants to talk, right? Things can get really, really scary if you're not sure if anyone's engaged at all, if anyone's listening. This is a big challenge. What's next is advancing our research projects. Research is just important to the team, right? To stay competitive, stay cutting edge, right? And to also research is interesting, right? But before, the way research would work in person is groups of people would exist. They would work on a research project with one of the old robots we have. In Zoom, we lost a lot of those people. We didn't have the same groups, and we didn't have the same robots, right? The main ways we got around this were simulations we coded and the ROMIs, which we just found, and we worked with them. They were successful. The next goal, right? It's like any other FRC team. Ultimate goal is competing in the yearly challenge or game. And as soon as the game came out, the main thing for us was motion profiling. And we needed to develop the code remotely in a way that it would still work on a real robot that we didn't have access to, and also with limited time, over Zoom, like that. And lastly is we don't want to lose the stuff we learned. We want to continue, the good habits we built up. We want to keep people around, right? Because we experienced a lot more growth over Zoom. And we want to keep this happening even if people aren't in their own homes while they're at robotics. And a few things that changed a lot were a lot of the stuff we just mentioned, right? The newbie ed, the activities simulations and stuff, and the research, right? And that leads us into newbie ed.
All right, so the way that we achieved our first goal of building an engaging newbie ed program, there's quite a few things. The first one was creating presentations. Remote lessons are very difficult, and they become even more difficult if you don't have presentations to teach. People miss meetings, they don't pay attention, they turn off their camera, they're not engaged. It's very useful to have presentations that you've produced be accessible after meetings, or just to help guide the meeting as it's happening. There are many times where we could link the presentation to the newbies, during the meeting or after the meeting, and if they felt like they had fallen behind, they were able to look at the presentation, take notes, or sort of follow along at their own pace. But in general, when it came to the structure of the meetings, the presentations were definitely a tremendous help with organizing what we were going to do that day. This is a little bit of a side note, but there was also a significant effect with the theme that we've created. Probably noticed a few other StuySplash presentations using this theme. Mr. Blaze, the awards meeting, and one of the other ones that's going on right now. Having a consistent theme for all of our slides helped a little bit with the newbie ed creation process, as it made it a more cohesive curriculum for newbie ed. This is an example of our previous year. It's not exactly clear the order or it's difficult to reuse them. But yeah, it also makes the slides reusable and super clear that it's a team resource, which encourages people to put a little bit more effort in as they know that it's representing the team that they're making the slides for. Another thing that we did to make newbie ed engaging was teaching through activities. We programmed in VS Code, which has a feature that we took advantage of called Live Share. Live Share lets you edit code similar to how you edit code with GitHub. And while for a robot project, it's still very useful to use Git when doing a short interactive lesson where everybody's coding at the same time, using Live Share can really help make it feel like a newbie who's programming is like actually having like a direct impact. And during remote learning, when it was very easy to sort of, just put the Zoom on in the background, it really helped get them to pay attention and become engaged as they were following along or even programming with us during the activity. In this example, we had a game of rock, paper, scissors, where each student would create a player class that would play rock, paper, or scissors. They could, in this case, Jin created a player that only did paper.
Not even a newbie.
Yeah, but there were other newbies that did random ones or would look for which ones were winning the most often. And these examples really helped make the newbie ed more engaging and definitely played a component in getting our retention higher. Teaching robot code. We used a ROMI to teach how to create robot code. We'll get more into what a ROMI is exactly. But we created super simple simulations, such as rockets, and had newbies program rockets. In the simulation, they'd all fly next to each other. We also made custom physics simulations to teach things about the limelight when we didn't have the limelight. And newbies were able to, in a similar fashion to the rock, paper, scissors game, program their own little robots in the simulations and have them run, and it helped with engagement. In this case, we'll get more into what this is exactly later, but this is a live stream of us testing a ROMI in my bedroom in a miniature field, which is another example of like an interactive component of our lessons. I believe this was a newbies code that we were running. The ROMI. There was another StuySplash presentation given on what the ROMI was in detail, but in case you don't know, the ROMI is a smaller robot that you can use to test FRC code. It uses like driver station, shuffleboard, WPI-lib. Everything that a normal robot does, you can do on the ROMI. It's just smaller and cheaper. And there's encoders and gyroscopes on it so that you can do things like motion profiling, which is super helpful. This really helped make our newbie ed more interactive.
Okay, yeah, so our second goal, advancing research projects. One big thing from year to year is passing down things we learn. And specifically control theory is really important because it's actually should be always used in the robot. A lot of the shooter, the drivetrain rely on it. And one specific way we taught the control theory really well was through building up methods rather than starting at the final product, which would be PID. We introduced what a control algorithm is with an error and a set point. And we started at bang, bang. We went to P, just P controllers, and then PID. And this is a slideshow I think Sam made for StuySplash a couple of years ago about these about controllers. But this is part of the place where our simulations came in. Can actually run several robots at the same time with different controllers. And see what the different effect is when you tell them to go 10 units forward or something. They all have these different algorithms controlling them. The next thing that really kicked in when infinite recharge at home, when we learned about it, was motion profiling. But one interesting thing with motion profiling is we had been trying to do it for years, but it never materialized to anything because it suffered from a lack of development time. Especially because it needs a lot of time with the robot. And like Mr. Belliveau was saying, the design could go on for weeks with a new robot. So SE might not have access to it all the time. and a lot of the knowledge was being shared. It might have been only one or two members who even knew like what motion profiling was. However, during quarantine, we had a lot of members, and it was our main focus. There was no robot being built. We were working off Edwin, so we had unlocked a lot of this time. And one of the ways we worked around, like not having the robot, actually making workable motion profiling was with the ROMI. And that worked out very well for us, as once we started testing motion profiling in person, transferring paths that we made to Edwin, we had a lot of success in infinite recharge. One of the last topics we often do is computer vision because of the limelight, and the robot's often shooting and aligning itself with things. So we didn't have the limelight either. We didn't have a robot, and there's no limelight. So we attached a camera to the ROMI, right? We programmed a camera server that was compatible with the ROMI, and then the ROMI unlocked vision. We focused on just like computer vision algorithms as well, just opening up a camera, having your Python code tell what's in the image. You can see that here, right? Sam. And then there's also Sam. Well, that's just color contouring, which we taught. So like the specific color in the image were being cut out. And we taught algorithms, a few of them like contouring, dilation, erosion, that you might see. When we come back to the limelight, new members will see that.
All right, so our third goal that we really wanted to emphasize when doing when operating SE last year was participating in Infinite Recharge at Home. So our goal during Infinite Recharge at Home as the software engineering department was the creation of new autons. So one of the challenges in Infinite Recharge at Home was the AutoNav challenge, which was a robot navigating a course autonomously, and you were scored based on how quickly you did it. We knew that our traditional methods of creating autons, such as moving, just move forward and then turn and then move forward again, would not cut it this year. So we had to really invest time into motion profiling. But this was going to be really difficult without the robot, especially because these autons, you really need time with the robot to optimize them. So yeah, not having access to the robot or lab. Our team heavily relies on the lab or just being in person. That's how we've operated for our team's entire history. Even the software engineering department, whether or not it was necessary to be in person, it's just how our team did things. And without the robot or lab or in-person communications, we had to really restructure the way that we organized or operated as a team. The use of slideshows, this was talked about a little bit before in newbie ed, also continued into the organization of meetings. We created a motion profiling curriculum as we learned new things so that every member of the SE department was able to create motion profiling autons. And by making the presentations, it allowed new members to review meetings that they might have missed. And it really helped guide things along and get everybody up to speed with what motion profiling was. And now, as we do motion profiling this year, for members that might not have been here last year, it's very easy to refer them to last year's curriculum. So collaborating with motion profiling. Now that we had a group of mostly new members who were experienced with motion profiling, we were able to break up into 4 groups, each of them doing one of the 4 paths that they had to follow. After getting Pathweaver set up on everyone's computer, they were able to work collaboratively in their groups on making the autons. And this was a really effective way of delegating work. It would have been impossible for any one of our members to program all of the paths themselves. And this is an example of the first path that we ever made. It's not super great. You can see a lot of unnecessary points, but it was something that we learned along the way. And then above there, you can see the merge, the pull request. You can see there's X's next to them, but that's unimportant. Those were successfully merged, and they were examples of the collaboration that was done on the team via teaching all of the new members how to do motion profiling. A miniature field at the ROMI. So we built a field in my bedroom that was about 1/6 the size of the real field that we were going to be driving on. And we did this because the ROMI is about 1/6 the size of a real robot. And when you scale it down, the driving characteristics of the ROMI are actually quite similar to the driving characteristics of our real robot. So by tuning for the ROMI on the small field, it was actually not that difficult to get it up and running on the bigger robot, which was a huge time save when it came to actually getting to the field and running the autons, because we did not actually have that much time to use the real robot. We were running all of our autons in a public park, I believe Russell Stage Park in Queens. We were on a squash court, and we had to make sure that the weather was nice on that day so that our robot didn't get rained on. And using the methods in the previous slides, whether it was the delegation of the creation of motion profiling autons or testing them on a miniature ROMI, it allowed us to save enough time to just barely get all of the autons ran and filmed on the robot so that we could compete in the competition. And we cut it close just because it was a very difficult task, but we pulled it off. And in my opinion, it was one of the crazier things that we've ever done as a team. So yeah, despite the really short amount of time we had, we were able to successfully compete and actually do pretty well.
Okay, yeah, so the last thing, right, continuing with in-person meetings. We don't want to lose our magic, so we continue in person, right? So we decided that our slides are really successful. The way we've been organizing lessons worked, right? Normally with SE, people phase out quite quickly after a couple of weeks of newbie ed, right? But as was mentioned, we had a lot of the freshmen that joined stuck around, which is really great. And we decided to think about why that was, right? And we thought that they were able to comprehend the newbie ed in a way that didn't leave them behind. But we also noticed some things with Zoom. It's like everyone has a laptop on Zoom. Everyone's at their own computer. Well, when I remember being a freshman in newbie ed, right, people in larger groups would be left behind. They wouldn't be able to code for the entire robotics meeting. Right? They might not even see the computer screen if a really large group, right? Specifically for creating slides, though, like I mentioned, the new members, they helped out a lot. We were able to actually make all these lessons up here, right? Also, the engaging activities. When everyone has a laptop, everyone can join a live share. Everyone can pull a repository and work on it. And we want the same effect in person. We want everyone to be engaged in person. And for this year, we have our folders. They're color-coded and numbered and named and very organized, unlike the 2019 newbie ed that was up there before, right? Yeah. All of them, I think here we had the slides, the activity, and a general date when we wanted it to happen. We hit a lot of those deadlines. That's why we have a lot of content in these folders. And yeah, it should be it.
So,
Yeah. Yes.
I didn't believe last year that we were ever going to get to run our infinite recharge at home robot, and you both showed an amazing amount of optimism on that. How did you maintain the positive focus throughout the season?
A lot of it was there's definitely a community within SE at the time. After the meetings would end, people would stick around, and it became a thing that a lot of people looked forward to because there was a lot of friendships that were built, but also we were also able to hit milestones that were engaging. The ROMI following a path for the first time was super awesome, and it was really difficult to comprehend that we could ever do that, or get a ROMI to follow a super specific path. And so things like that were super motivating. And then Path Weaver was easy enough for a lot of the newbies. And I don't know, I'm not exactly sure what compelled that many newbies to stick around. but they seemed engaged and they have continued that engagement into this year.
My question was about the two of you. Like, did you believe that we were going to get to compete, or were you just able to be positive in hopes that we could?
Oh, I mean, yeah, I guess me and Myles were pretty interested in it, so we didn't really have many doubts that we could get it to work, but
Yeah.
yeah, it was mainly just like getting the new members to, like, if me and Myles really wanted to, we could spend a lot of time on our own programming it, but our goal is to like keep everybody engaged and help it continue in the future years.
Another question. The pandemic isn't over yet. Do you have any advice for other teams about how they can rebuild or continue through this resource constrained season?
So for engineering, I'm not all that sure how much I can answer that.
Oh, sorry,
But-
other teams, like actual other teams in their SE departments?
So yeah, when it comes to running SE, it's just like, let me think. So for an SE department, you really need to make sure that you have members that are like truly invested in programming. We're lucky enough to have quite a few of those. Those members that are really dedicated about programming, like giving them the resources to test their code. I know it's not super interesting when a programmer tests their code because it's time you could be spending building on a robot, but can really help advance the research. Or like investing into things like a ROMI can definitely help like highly accelerate any of the programmers on your team.
Feel free to answer this question in only as much detail as you feel like getting into, but I found it really interesting that you view a big part of what you do as research to kind of stay on the cutting edge and keep pushing what your abilities are, and I love the sound of that. So my question is, regarding the research portion of what you do, where are you looking when you're doing the looking for external part of your research?
So a lot of the research that we do is based on like inspiration from other teams. Like other teams did motion profiling before we did, or other teams did like PID before we did. So those are obvious goals. Like we saw what they could achieve by doing that. And these were really things that we had our eye on for like a long time. But just like looking to other teams and seeing like how they accomplish things through programming, like really good programming can make up a huge difference in like any mechanisms if it's controlled correctly. And so there's a lot of resources, even on like just WPI's website, of how to get motion profiling working or how to get PID working. And so our research is really making sure that our students understand everything on that website. Because WPI lays out almost everything for you, but it's not really useful until you have a member who knows how to read it. And so that's the big thing, is really getting members like actively looking out for projects that are probably already there for them.
I want to add to that, also having a member who's passionate about that topic. Like you created StuyLib, we had tried to do that a few years ago, but nobody was interested enough to it, so it fizzled and died. So you need both the idea and somebody to champion it through to working.
All right. It looks like that was all of the questions. So if that's it, then I guess you can. I guess Max isn't here to end the recording, but yeah.